alongside graphing the curve of the quadratic is analyzing the key characteristics of the quadratic. So once you have a graph, these are some of the questions and characteristics that we're interested in, such as the transformation. So looking at the graph, when we're thinking about transformation, that is left or right, up, down, is it moving faster, slower, and reflected, just like first unit. So looking at this graph, in words, we can see that the vertex is at 1, -3. So we move to the right 1, we move down 3, and based on the graph, it may be hard to tell if it was stretched or slow or faster, but looking at the equation, we can see what the a value is. So a is 1/2, so we can say it's 1/2 as fast as the parent. It's all compared to the basic parent quadratic. All right, and then our coordinate notation, that would be the xy becomes, this would be x plus 1, because it went right 1, and then 1/2 y minus 3. So it's going up half as fast, and then it shifted down 3. Okay, the axis of symmetry. This is the equation of that reflection line that we use to plot the points. The other videos, we would plot a couple points around the vertex, and then we would reflect them over. So when we say axis of symmetry, that is that line that we were reflecting over. And since it's a line, it's an equation. As a vertical line, it would have the equation x equals something. And in this case, the x value of that line was at 1. So the axis of symmetry for this quadratic is x equals 1. It's always the x value of the vertex, because the vertex is always in the middle of the graph. Wherever the vertex is, whatever that x location is the axis of symmetry. So x equals 1. The domain of the quadratic, well, domain of any quadratic is all real numbers, -infinity to +infinity. And then the range, so those are the heights. In this case, it has a minimum of -3, and it doesn't have a maximum, so it just goes on forever, positively. And then the end behavior of this quadratic, well, we see that it opens up. So as x approaches +infinity, y would approach +infinity. And as x approaches -infinity, aka as x moves to the left, the function is still moving up. So no matter whether x goes to the right or as x moves to the left, our function is going up. So those are the characteristics of the graphs that we like. Some other things that will be asked for are the x and y intercepts. So the x-intercept of this function, visually, it looks like it's about -1.5 and 3.5. We may have to calculate that. And we also would be interested in the y-intercept, which in this case is just the -5/2. But the top info will be standardly asked. The transformations, axis of symmetry, domain range, and end behavior.